Hi and welcome back to the slightly more complex example of finding the areas where there's an x-intercept to deal with. So this time we talked about the difference between definite integral and areas. In the last video, I'll just find the area in this video. And the function is y equals 2x cubed minus x minus 1. I've designed this very particularly. Now, I'm going to draw the function, but let's pretend you don't know much about it. So my function starts when I put in x equals 0, I get negative 1. When I put in x equals 4, which is where we're going to go to, that'll be our upper boundary or our upper terminal, I get 4 cubed is 64, 128 minus 5 is 124, minus 1 is 123. So it goes right up here to 123. You can see my scale is already out, but you know, this is not, the question is not about a neat diagram, the question is about finding the area. And it's a cubic, so it actually looks a bit like this. Have I got this right? I think so, something like that. Okay? Anyway, at some point it sort of drops off like that or whatever. I don't know a lot about it. What I do know though is it starts below the x-axis and finishes above the x-axis. So there is a point of intersection. Now, cubics can also look like this. So there might be 3 points of intersection. I have to be really careful here. As soon as I determine though that this is just not a simple case and that I've got a point of intersection, then I've got to go ahead and find those points of intersection. If it's a technology active paper, well, you could probably go through now and find them using technology. Great, get on and do it, particularly if it's multiple choice. If it's technology active, grab your calculator and sketch it so you know you've got a point of, in fact, find it. And if you still need to do the working, well then do the working, but at least you know the answer. If it's a tech-free paper, things are a little bit more tricky, but not impossible. So let's start with some working over here, and I'm going to have to be a little bit conservative about space. Let's assume in this case, because you're not really required to solve cubics, let's assume it's a tech-active paper. And I can use the tech-active paper to show just mathematically that there is only one intersection point and that that intersection point is x equals 1. So I'm going to use the tech-active capabilities to do that. So first I'm going to show that if I factorise this, x minus 1 is a factor. So I could do polynomial division now. What I'm going to do instead is just a bit of a logical approach, and that is to say, well, x times what will give me 2x cubed, this must be 2x squared. Negative 1 times what will give me that negative 1, this must be plus 1. And with a little bit of logical approach here, negative 1 times x, negative x will give me positive x. Negative 1 times, I need to get 1 negative x, and x times 1 will give me positive x, so I need to subtract 2x, but actually that negative 2x times negative 1, that needs to be positive. That gives me my negative x overall, and I test it and it works, whatever you do. Go back and practice that skill if you need to, but for now, I know that x equals 1 is one of my x-axis intercepts, and here's the other factor, it's quadratic. I can do a little test on this quadratic as well, because is there 1 or is there 3? Well, let's take this and have a quick look at the discriminant, b squared minus 4ac. So remember, this is our way of working out whether quadratic is solvable. If it's solvable, there's 2 more roots. They might be over here, but they might be inside our boundary. So I just put that in, and I get 2 squared minus 4 times 1 times 2, and that's equal to 4 minus 8, which is negative 4, which is negative, and therefore this is not solvable in the real numbers. There's no real solutions, so we can leave it. We're doing mathematical methods. There is only one solution. It's here at 1. We've got our split. We now need to find this area and this area. And I dare say this area is going to be significantly larger than that area, but we still need to find them both. Okay, so let's go and do that. I feel like I've been neglecting green, so we'll go through and do this in green. Let's integrate. Let's find area 1 first of all. Area 1 is going to be here, so it's going to be between 1 and 0 of 2x cubed minus x minus 1 dx, and that will be this. 2x cubed becomes 2x to the power 4 over 4 minus a half x squared minus x between 1 and 0, And when I substitute my 1 and 0 there, 2 over 4 becomes a half. And I don't have to do this integration again later on for area 2. But I get 1 to the power of 4 over 2 minus a half times 1 squared minus 1 minus 0 to the power of 4 over 2, a half times 0 squared minus 1 times, so minus 0, substitution there, and that gives me a half minus a half minus 1, and then minus 0, which gives me negative 1. But I want the positive area, so area 1 is equal to 1. So that's got an area of 1, but it comes out as negative 1 in the definite integration. And space is a bit precious on this board, but I want to keep it all here, so you've got it all. So I'm going to really muck up my working by putting area 2, in fact I might even do it in a different colour, so it's obvious. We'll do area 2 in pink. Area 2 here is the integral between 4 and 1 of x cubed minus x minus 1. And I'm going to have to be a little bit space conservative. Now I've done an integration before, so why repeat it? I'll just write down the answer, x to the power of 4 over 2 minus x squared over 2 minus x. And now I'll write down my substitution line, and that is 4 to the power of 4 over 2 minus 4 squared over 2 minus 4. Subtract from that 1 to the power of 4 over 2 minus 1 squared over 2 minus 1. And now I have to do that evaluation. So 4 to the power of 4 over 2, and you'll just put this in your calculator, but I don't want to pick one up now, minus 8 minus 4, so you might want to check, hopefully I get this right, and then I get a half minus 1, and that gives me 128, gives me 116 minus 1, which is 115. And so I've got an area here of 115, an area here of 1, and my total area, if I go back to green, area total is equal to area 1 plus area 2, absolute values to make sure that they come out positive, 1 plus 115, and that is 116. Now for those of you watching and thinking about this carefully, you'll notice here that there's a little special property in that because I've made this one negative, it's kind of the hinge point. So 115 is a special value, and I get 116 as the area, but if this becomes negative, I get 114. And 115 is always that median, and I get whatever area 1 is either side for my definite or my area answer. Anyway, that's a bit more complex. You could get this in a polynomial form, exponential, log, periodic function, whatever form. The process is the same. Find a point of intersection and then evaluate, and maybe do your working a little bit better than me. All the best.